This question is from GATE Mechanical Engineering of 2012. This is question number 40. The question is, a large tank with a nozzle attached contains 3 immiscible inviscid fluids as shown, assuming that the change in H1, H2 and H3 are negligible. The instantaneous discharge velocity is, so we need to find here instantaneous discharge velocity. So what we can do, we can assume this as this line. This is the datum line, so this is, let's say this is point A, and at the exit, let's say this is point 2. This is point 1 and 2, not A, 1. Okay, so we can apply the Bernoulli's theorem between these 2 points so that we can get the instantaneous discharge velocity, that is the velocity at point 2. Okay, so apply Bernoulli's theorem. Let's write here itself. Apply Bernoulli's theorem. Okay, between point 1 and 2. So what we can write here using Bernoulli's theorem, so P1 upon, so the density here is rho 3 times G plus V1 square upon 2G, we are writing for point 1, plus Z1, the potential energy head, that will be equal to P2 upon rho 3G, the density remains same here, plus V2 square upon 2G plus Z2. Now we observe here that the datum line is same for 1 and as well as 2, right? So Z1 is equal to Z2. Okay, also the velocity at point 1 is 0, right, and the pressure at 2 at the exit of this nozzle will be 0. So V1 is equal to 0 as well as P2 is equal to 0. Now if we substitute all this, so what we'll get, this equation we can write again, we can write as, so this will be P1 upon rho 3 times G plus V1 is 0, so this we can write 0 is equal to this P2 is 0, so let's write 0 plus V2 square upon 2G. Now from here we need to find, now we can cancel G from here, right? Directly we can do that, and Z1 is equal to Z2, so both will get cancelled out. Now total pressure at 1, let's write P1. What will be the value of P1? It is the hydrostatic pressure because of this height H1, because of all these 3 liquids. So at 1 the pressure will be P1 is equal to rho 1 G H1 because of this liquid plus rho 2 G H2 because of this liquid plus rho 3 G H3. Okay, so this will be the pressure at point 1. Let's substitute it here in this equation. So we'll get rho 1 G H1 plus rho 2 G H2 plus rho 3 G H3 upon rho 3 times G is equal to V2 square upon 2G. Okay, G we have already cancelled, so no need to write here again. So from here we can write V2 square actually is equal to 2, and we can take G common, so 2G into H3 also, let's take H3 common. So what we can write, this will be rho 1 H1 upon rho 3 H3 plus rho 2 H2 upon rho 3 H3 plus 1. Fine. Now V2 will be equal to, we'll just put a square root over this, so square root of 2G H3 rho 1 H1 upon rho 3 H3 plus rho 2 H2 upon rho 3 H3 plus 1. Okay, so let's match with the given options. So we can see here option A is the correct choice. So for more information you can refer to the NPTEL course lecture number 7, Bernoulli's equation on advanced concepts in fluid mechanics by Professor Suman Chakraborty of the Department of Mechanical Engineering at IIT Kharagpur.